Hello everyone, my name is Nguyễn Anh Tuấn. My student ID is G67367448. And today I will be presenting my project. Title is Predicting Stroke Risk Using Supervised Classification Methods. So this project was completed as a part of the course Data Mining and Part Knowledge Discovery. Stroke continues to be one of the major causes of mortality and long-term disability worldwide. Because of this, early detection is extremely important. It allows earlier preventions and more timely treatment. In this study, my goal was to use machine learning to predict a patient's risk of stroke based on their demographic, health, and lifestyle information. The dataset that I use in this project is Cargo Stroke Prediction dataset, which contains 5,110 patient reports. So for this project's objectives, the project has five main objectives. Implements multi-supervised classification model, address data quality issues and severe class imbalance in the datasets, evaluate the models using metrics such as accuracy, precision, uh, we call F1 and ROC, AOC. Identify the key factor that contributes most to the stroke risk, and finally provide insights and discuss important ethical concerns when applying machine learning in healthcare. So for the dataset overview, so here's is the overview of the datasets. In total, there are 5,110 patient reports. The features include demographics, such as age, gender, and resident type, health factors such as hypertension, heart disease, glucose level, and BMI, and lifestyle factors like smoking status and work type. The target variables is whether the patient had a stroke or not, and the major challenge in this dataset is that only around 5% of the patient had a stroke, which means the data is highly imbalanced. To do the pre-processing steps to prepare the data set for modeling, I perform several modeling steps. So first, for the missing BMI, uh, values were fused using the median. Second, for the glucose outliers, were clipped using the IQR method to reduce extreme values. For the category variables was encoding using one-hot encoding. For numerical features such as age, glucose, and BMI were scaled using standard scaler. So for the SMOCE was applied to oversample the minority class and reduce imbalance. Finally, the dataset was split into training and testing sets using an 80 over an 20% stratified split. So these steps help ensure the data is clean, balanced, and suitable for machine learning model. For the model implement, for the model implemented, I implemented four supervised learning models. Naive-Bayes here nearest neighbors with k equals 7, decision tree, and linear discriminant analysis or LDA. So all models were evaluated using five-fold cross-validation, followed by testing on the test set. I also examined confusion metric and ROC curve to better understand each model's strengths and weaknesses. So for cross-validation results, so here are the cross-validation results for all four models. For the naive Bayes has extremely high in recall of 0.99, but the precision is very low. For the KNN, shows moderate performance overall. The decision trees has high accuracy but perform poorly in terms of recalls, and LDAs have the best balance with a strong recall and the highest AUC of 0.84. So for the key takeaways here is that the LDA offer the best trade-off between correctly detecting stroke cases and keeping errors manageable. And for the confusion matrix, so we can referencing the four matrices on this page. So look at the confusion matrix, make the model behavior very clear. Night-based predict almost every patient's stroke, so it catched nearly all stroke cases, but produced too many false positives. For dysentery misses most of the stroke case, it predicts almost everyone has no stroke. For the KNN performance, moderately, but still misses quite a few stroke cases. And for the LDA, offer the most balanced result with relatively low false negative and false positives. So for this visuals comparison, the LDA appears to be the most practical model for the medical use. It's had the best balance. And for the ROC curves, there are the ROC curve for all models. We can clearly see that the LDAs and naive Bayes have the strongest ranking ability, with the LDA achieving the highest AUC of 0.85. For the KNN performs moderately, while decision trees ROC curves is close to the diagonal lines, meaning it's performed only slightly better than random guessings. Once again, LDA stand out as the best performing model overall. For the key insights, for the features important and the LDA coefficients. So exam means the features important for the decision tree and discriminants coefficients from the LDA model. The key insight, like for the ACE, is the strongest predictor of stroke risk. For the high glucose level and high BMI, significant increasing the risk. For the hypertension is also the major contributor. And for the smoking status, behaviors is a noticeable impact. For the work type, actually also show the social economist influence. So these findings are consistent with well-known medical research, which helps validate the model. For the ethical consideration, using machine learning in healthcare comes with important ethical responsibility. False negatives can be dangerous because missing a true stroke case can lead to delayed treatment. False positive can cause unnecessary stress and waste healthcare resources. And there are also bias concerns. For example, the other genders categories had very few samples. And the SMOTs may distort patterns if not used carefully. Interpretability is also important because medical professionals need to understand how predictions are made. And finally, these models should always support rather than replace clinical decision making. So for the conclusion and future work, in the conclusion, the LDA is the most suitable model for predicting stroke risk, and it provides the highest AUC, strong recall, and a balanced overall performance. Its behaviors also aligns well with medical knowledge, especially regarding risk factors such as age, glucose level, BMI, hypertension, and smoking. And for the future work, I plan to apply the hyperparameter tuning, use ensemble models such as XGBoost and random forest. Apply cost sensitivity learning to reduce the false negatives, use model calibrations, and expand the datasets with more medical features. Thank you very much for listening. And I'm happy to answer any question you may have. Thank you.